Okay, the first couple of questions are on particle motion. So a particle motion moves along the x-axis. The position of the particle can be found by x of t is equal to sine of 2t. Find the acceleration of the particle at t equals pi over 2. Okay, so I know that velocity is the derivative of position and acceleration is the derivative of velocity. So we have to find the second derivative of this function. So I know velocity is going to be the derivative of sine is cosine, but I have to do chain rule because the input is not just a t, so I have to multiply this by 2. So my velocity is equal to 2 cosine 2t. And then my acceleration is going to be the derivative of this. So the derivative of cosine is negative sine. So it's 2 times negative sine of 2t. And then I have to take chain rule of the input as well. So I need to multiply this by 2. So my acceleration is going to be negative 4 sine of 2t. And then so now I just plug in pi over 2. So the acceleration of pi over 2 is equal to negative 4 sine of 2 times pi over 2. And this is equal to negative 4 sine of pi. The sine of pi of 0 is 0. So that means the acceleration of pi at pi over 2 is equal to 0. Okay. Number 2, it says the position of the particle is given by this function. When is the particle speeding up? So here, remember, velocity and acceleration. If velocity and acceleration are the same sign, we are speeding up. If velocity and acceleration are different signs, then we are slowing down. So let's find the velocity function. So velocity function, so I'm going to use power rule here. 3 times 1/3 is 1. And so this is just t squared minus 10t plus 21. Okay. So since we need to know when the particle is speeding up, we need to know when velocity is positive and when velocity is negative. So we have to go ahead and do our sign analysis here. Well, first we have the factor so that we know when velocity is equal to 0. So this is t minus 3, t minus 7. There should be a simple sign analysis here. If we pick a number bigger than 8, these are both positive. If we pick a number between 3 and 7, this is positive, this is negative, so it's negative. And if we pick a number like 0, this is negative, this is negative, negative times negative is positive. Okay, so velocity is positive here and here, and it's negative here. Okay, so now let's go ahead and find acceleration. We have to take the derivative of velocity. That's 2t minus 10. And this should be fairly simple. I know that this is going to be equal to 0 at 5. Right? Because when 2t minus 10 is equal to 0, then t is equal to 5. So obviously, if a number is bigger than 5, like 6 times 2 is 12, 12 minus 10 is positive 2, so this is positive. And if we pick a number less than 5, then if we plug it into here, it's negative. So this is the sign for velocity. This is the sign for acceleration. So when is the particle speeding up? It needs to be when they are either both negative or both positive. Now, velocity is positive until 3, and then it becomes negative. And the acceleration is negative until 5. So for between 3 and 5, I'm speeding up. Okay. So the particle is speeding up on the intervals. So from 3 to 5. See, because between 3 and 7, it's negative. But here, less than 5 is negative. So that means in the section between 3 and 5, these are both negative. So it's speeding up. And then after 5 here, it's positive. And then after 7 here is positive. So, and 7 is less than t is less than or equal to 10. Make sure my time interval here ends at 10. So make sure you put that it ends at 10. And the 10 is going to have a less than or equal to because t ends there. Or actually, we don't need to put that there. My bad. Because velocity and acceleration have the same sign. Okay, so now we have a graph and we are supposed to answer these questions. So this graph is a velocity graph. So it's a velocity graph. On what intervals is the object speeding up? So just like number 2, it's speeding up when velocity and acceleration are the same sign. So velocity is positive until here, and then after here, it's negative. Now, how do we find acceleration? Well, remember, acceleration is the slope, is the derivative of velocity. So we just have to look at the slope of these portions of the graph, and that will tell us if acceleration is positive or negative. So you see how this is, the slope here is negative. So that means acceleration is negative here. This is horizontal, so acceleration here is 0. That's the slope here, 0. Acceleration here is positive. Acceleration is negative, and then acceleration is negative. So let's see where it's speeding up. Well, if you look at portion C, velocity is positive because it's above the x-axis. Acceleration is positive because it has a positive slope. So I know C for sure it's speeding up. But is there another section besides C? Well, look down here at E. So E, the velocity is negative because it's below the x-axis. But then acceleration is also negative because my slope is negative. So for letter E, velocity and acceleration are negative, so it's also speeding up here. So letter C and letters E, the object is speeding up. Now, number 4, the object reverses direction at t equals. Now, remember, here velocity is positive, so it's always going to the right here. But then here, when it's negative, now it's moving to the left. So right here is when it reverses direction at 10 only. Number 5, for what time t does the object attain its maximum acceleration? Okay, now let's look at our options here. 0 to 2, 2 to 6, 6 to 8, right here at t equals 8, or from 8 to 10. Okay, well, we can eliminate A and D, or from 0 to 2, and also from, what is this, 8 to 10. Why? Because acceleration is negative, right? Acceleration is negative, so these are going to be greater than a negative acceleration because they're positive. Now, 2 is less than t is less than 6. 2 is less than t is less than 6 is this horizontal line, and the acceleration is 0, whereas here the acceleration is positive. It's greater than 0 because it's a positive line. So it's not from 2 to 6. Now, is it C or is it D? Well, it's C, because at the specific point, acceleration is 0, because at this point, your tangent line is, you actually don't have an, I'm sorry, you're not tangent at this point. So you're undefined. Remember how you cannot have a derivative at a point or a cusp, right? So there actually is no derivative at this point. That's what I meant to say. So it's not t equals 8. There is no derivative at a point or a cusp on a function. And we learned that back in chapter 2. So 6 to 8 is your maximum acceleration. Now number 6, on what intervals is the object slowing down? So this is when velocity and acceleration are different signs. Okay. So it's not B. It can't be B only because this is a 0 acceleration. So it's not speeding up or slowing down at this time. Okay. Now, if we look at letter A, are we slowing down here? And the answer is yes. It's because velocity is positive since this graph is above the x-axis, but the derivative or the slope is negative. So velocity and acceleration are opposite at A. Same thing goes with D, right? Right here, my velocity is positive because it's above the x-axis, but acceleration is negative because the slope is negative. Okay, so it's actually A and D. Letter E, you're actually speeding up as we answered for number 3, right? Okay, let's move on. So number 7 and 8 is just practice for you writing how to apply the derivative in different contexts. So it says during a hurricane in Central Florida, the amount of rainfall in centimeters is a function of time. Let R equals f of t define the amount of rain recorded by meteorologists beginning at midnight. Give an interpretation of the statement f prime of 6 is equal to 0.5. So 6 is in place of t, so 6 represents the time, and we are recording beginning at midnight, so we could say if t equals 6, then it's at 6 a.m. Okay, so remember that it's a derivative, so this is a rate of change. Okay, it's positive, so it's increasing, not decreasing. And what are we measuring? We are measuring the amount of rainfall in centimeters. Okay, so we could just simply say at 6 a.m. the rate of rainfall is increasing by 0.5 centimeters per hour. Or you could write per hour, right? But it's always just whatever this is per the time. Okay, so number 8 doesn't involve time actually. So let's go ahead and do number 8 now. It says when a patient is prescribed an antibiotic to fight off infection, the dose in milligrams is a function of the patient's weight. In pounds, let D equals F of W define the dosage. Interpret the meaning of the statement F prime of 135 is equal to 2.5. So 135 represents W, which is the patient's weight. And then 2.5 is the rate that the dosage. Okay, so 2.5 is the dose is increasing by 2.5 milligrams. So I could just say the rate of antibiotic for a patient who weighs 135 pounds is increasing at 2.5 milligrams per pound. Okay, so please note that this is W is our input variable, which is pound, right? And our output variable is D, which is milligrams, so we're increasing at milligrams per pound. Number 9, number 10, and number 11 are related rate questions. A ladder is 10 meters long, is leaning against a vertical wall with its other end on the ground. The top end of the ladder is sliding down the wall. When the top end is 6 meters from the ground, it is sliding down at 2 meters per second. Okay, so I know oops, okay. So I know this is 10. Okay. And I know we are sliding down at 2 meters per second. And we want to know how fast is the bottom moving away from the wall at this instant. So here we want to find dx dt. Okay. So since this is a right triangle, I could use Pythagorean theorem. So I know that x squared plus y squared is equal to 100. Because 10 is the ladder, is going to be the length no matter what. So if I square it, it's 100. Remember, a squared plus b squared equals c squared. And I put this as x, this as y. Okay, we are given that our dy dt is moving down the wall. So I know it's dy dt that's given to us, and it's minus 2 meters per second. And we want to find what dx dt is when y is equal to 6. it says when the top end is 6 meters from the ground. So when the top end is 6 meters from the ground, so we want to find dx dt when y is equal to 6. Okay, so we are going to start with our formula here. X squared plus y squared is equal to 100. We are going to do implicit differentiation, and we're going to do it in differentiate in terms of t. So this is 2x dx dt plus 2y dy dt is equal to 0. So we did implicit differentiation there. And we want to find dx dt. So I'm going to go ahead and solve for dx dt. So I have 2x dx dt is equal to negative 2y dy dt. Divide everything by 2x. And so I know dx dt is equal to negative y dy dt all over x. So I'm going to go ahead and plug everything in. I have dy dt. I have y is going to be equal to 6, but I don't have what x is. So that must mean I must use the fact that it's a right triangle again to figure out when y is 6, what is x. And you could actually do this step in the very beginning instead of waiting at the very end. You could do that step first and then do this step after. But let's go ahead and do this. So what happens if I have a right triangle? And at this specific moment, this is 6, this is 10, and we are trying to find x. So I have x squared plus 36 is equal to 100. Remember, a squared plus b squared equals c squared. I have x squared is equal to 64. And so that means x is equal to 8. So now I'm just going to go ahead and plug everything back here to figure out what dx dt is. So this is going to be equal to negative, okay. So it's negative 2. Wait, sorry. I'm going to input it in exactly like how it is. Negative y is 6, dy dt is negative 2, and then x is 8. So this is going to be negative 12 on the top, and it's going to become a positive 12. So it's 12 over 8. Which we could make it equal to 3/2 or 1.5. So this is 3/2, and we were solving for dx dt, so it's going to be meters per second. Or you can make it 1.5. Number 10, a right circular cylinder of constant volume is being flattened. So we actually take a cylinder and we're going to flatten it. At the moment when its radius is 3 centimeters, the height is 4 centimeters, and the height is decreased at the rate of 0.2 centimeters per second. At that moment, what is the rate of change of the radius? And the volume of the cylinder is volume is equal to pi r squared h. Okay, this is a fairly straightforward problem. There's no really bells and whistles behind this one. We know that volume is equal to pi r squared h. We are given oh, actually, there is a little kind of trick here. We are given that height dh dt is decreasing at a rate of 0.2 centimeters per second. And we want to find what is the rate of change of the radius. Okay. So we want to know dr dt when its radius is 3 centimeters, so when r equals 3 and h is equal to 4. Okay, so what we're going to do now is we're going to start with this formula. And we're going to go ahead and, whoops. We're going to start with this formula, and then we are going to do implicit differentiation here. If we do implicit differentiation, we get dv dt is equal to, now we have to do product rule here because we have two separate variables. So it's going to be, this is my first function pi r squared and my second function is h. So it's going to be pi r squared. So this is the first times the derivative of the second. The derivative of h is dh dt, because the derivative of h is 1, but don't forget we're differentiating with respect to t, plus the second function times the derivative of the first. The derivative of the first is a power rule, so it's going to be 2 pi r dr dt. Okay, now there are a couple of things that we can do with this equation. If you actually look back at the question, it says the circular cylinder has constant volume. So that means the volume is not changing. So that means dv dt, so that means v is a constant now. And so the derivative of a constant is 0. Okay. So because the volume is constant, then that means there is no change in volume. So that's why this is 0. So now I'm just going to go ahead and solve for dr dt. So I'm going to move this to the other side. And I have negative pi r squared dh dt is equal to h times 2 pi r dr dt. I'm going to divide everything by h times 2 pi r, h times 2 pi r. So all of that cancels. The pi's cancel. This r cancels with one of the r's on top. So let's clean this up a bit. Dr dt is equal to negative r dh dt all over 2h. Okay, so now we can go ahead and plug everything in. It's going to be negative, my r is 3. My change in height is negative 0.2. 2 times the height is 4. And this is going to be, you could just put that in a calculator. So the top is 0.6, the bottom is 8. So this is actually 0.075 centimeters per second. Okay. Obviously, if the question, instead of saying it had a constant volume, but it also gave you a dv dt, you would plug that in for this. Okay, let's move on to the last related rate question. So number 11, a man 6 feet tall walks at a rate of 5 feet per second towards a street light that is 16 feet above the ground. At what rate is the length of his shadow changing when he is 10 feet from the base of the light? So all of these questions are the same. There's really just one trick to them, and it's just setting up similar triangles. So we're going to have one big light, and then this is 16. There is a man standing here, and there is, so there's a light that's casted across him, and he's 6 feet tall. Now we want to know what is the rate of the length of his shadow changing when he is 10 feet from the base of the light. Okay. So what we're doing is we're basically creating a similar triangle situation here. Now, actually, I'm not going to draw this line. The line will be the man. So we want to know the length, the rate that the shadow is changing. So we'll call that y. The shadow's length is y from the man to here, where the end of his shadow is. So this is the light, right? Bright light shining here. But they are also talking about, there's another distance that we'll call x here. And that's how far he is from the lamppost. So whenever you have one of these problems, you're going to set up a proportion. So you basically have two triangles here that are similar. And if you don't see them, if you have a hard time seeing what's happening, you have a big triangle here that is 16, and on the bottom, it's x plus y. And then you have another smaller triangle here that is 6 and y. But because for geometry, since they share the same angles, you know that they are similar triangles. So you could just set up a proportion that this side and this side are in proportion, and this side and this side are in a proportion. So what I could do is I could do 16 over 6 is equal to, so this is big over small is equal to the base of the big triangle over the base of the small triangle. And now all you have to do is just cross multiply. So this is going to be 16y is equal to 6x plus 6y. Since we want to know the rate that the shadow is changing, that is y, so we're going to solve for y here. So if I subtract 6y from both sides, I get 10y is equal to 6x. Divide both sides by y. Divide both sides by 10, and I get y is equal to 6 over 10x, which we could also say that y is equal to 3/5 x. Okay. Now, all we want to do here is, if this is the formula we are going to use, right? We're going to go ahead and just take the derivative. We're going to do implicit differentiation with respect to t. So I am going to have dy dt is equal to 3/5 dx dt. And so now I'm solving for dy dt, since y is the shadow length, and I'm asking the rate at which the length of his shadow is changing. So I'm solving for dy dt. So now I know dx dt. Oh, and I apologize. I didn't set up my what we know, what we're given, and all of that stuff. But our dx dt is 5 feet per second. So it says a man 6 feet tall walks at a rate of 5 feet per second towards a street light. Okay. So if he's walking towards the street light, then what that means is x is getting smaller, right? So if x is the distance between him and the lamppost, then that means if he's walking 5 feet per second toward a street light, x is getting smaller. So that means our dx dt is going to be -5, not +5. +5 would be if he's walking away from the street light. If he's walking toward the street light, it's negative. So dy dt is equal to 3/5 times -5. And so that means dy dt is equal to, I just cross these out, and this is equal to -3 feet per second. Letter B is pretty straightforward. At what rate is the tip of his shadow moving? So the tip of the shadow is actually kind of easy because the tip of the shadow can be found from just adding x and y. So once again, this is the tip. So x and y is the total distance of the tip of the shadow. So if you just want to know what the rate of the tip of a shadow is moving, we are just looking for the derivative, the change of x plus y with respect to time. But if you remember from back in chapter 2, if you are adding two derivatives, if you're taking the derivative of a sum, it's the same thing as the sum of the derivatives. And we already have dx dt and dy dt. Dx dt was -5 and dy dt was -3. So this is going to be -8 feet per second. And let me just put this up here so you know that the given is you're walking toward a street light, so it's -5 feet per second. Once again, if you're walking away from the street light, then x is getting larger, so x would be positive. If you're walking toward the street light, it's negative because you're making x smaller. But basically, anytime you see this question, all you have to do is just set up the similar triangles, set up the proportion and solve for y, and then now just differentiating both sides and plugging things in. Okay. Number 12, a law firm pays a third party to pick up confidential documents and deliver them to a shredding service. The cost in dollars is a function of the weight of paper in pounds that is shredded for each client's case. Specific values of C prime of W is given below. Okay, cool. The cost to shred 80 pounds of paper is $55. Estimate the cost of shredding 82 pounds of paper by using the tangent line approximation at t equals 80. Okay, so we're doing linear approximation here. And they gave us a table. Now, the table is actually kind of makes it easy. So we want to estimate the cost of shredding 82 pounds, and we're going to use a tangent line approximation at t equals 80. So everything else doesn't really matter here. All I'm really focusing is here. Now, my derivative is 1.25, cool. But remember, we need a point and we need a slope. So I found my slope. Where is my point? Well, right here is, I know my function. So this is the derivative. So then that means my function is C of W, right? So just be aware that you're aware of function notation. W is my input, C is my output. So W is the weight of paper. So it says the cost to shred 80 pounds of paper is $55. So that means this is my X and this is my Y. So I know it goes through the point 80, 55. And I know my slope is 1.25. So this is pretty straightforward. It's y minus 55 is equal to 1.25 x minus 80. So L of x, so I'm just going to do my linear approximation, is equal to 1.25 x minus 80 plus 55. And what I'm going to do is I'm going to use that approximation to go ahead and estimate the cost of shredding 82 pounds of paper. So L of 82 is equal to 1.25, 82 minus 80 plus 55. And this should be pretty simple. You could do it on a calculator, but this is just 2 times $1.25 is $2.50. 250 plus 55, this is 57.50. Okay. And so that I know that C of 82 is approximately $57.50. Number 13, given the implicit curve x squared minus ln of x over y is equal to 1, write the linear approximation of the tangent line at 1, 1. Okay, so I have an implicit curve. That means I have to use implicit differentiation here. The only thing is, make sure, just like on the last test, if I am using a logarithm and I'm using a quotient, it's always easier to split this up into a subtraction. So let's go ahead and do that first. X squared minus, make sure since I'm breaking this up, you put the difference in parentheses. So what I mean by that, this is going back to your Algebra 2 days. Make sure that you don't leave out these parentheses. If you leave them out, you're going to get something that's completely different. Because when you put a parentheses after that, remember, whenever you are subtracting this entire thing, if you split it up into an equivalent expression, you're still subtracting this entire thing. So make sure you put that in parentheses. So let me just distribute the negative in. And that is my function. So this is just rewriting this so that it's nicer for me to differentiate. Because otherwise you would be using a chain rule and a quotient rule here, which is ugly. So let's go ahead and differentiate this implicitly. So this is 2x minus 1 over x plus 1 over y, but since we need to take the derivative with respect to x, this is dy dx is equal to 0. So I am going to solve for dy dx. So I have 1 over y dy dx is equal to, I'm going to bring this to the other side, 1 over x minus 2x. And then I'm going to multiply both sides by y. And I get dy dx is equal to 1 over x minus 2x times y. And now we'll just go ahead and plug in the point 1, 1. So this is 1 over 1 minus 2 times 1 times 1. And I'll just do the math here. This is 1 minus 2, which is negative 1. Negative 1 times 1 is negative 1. So if I'm going to write the linear approximation, this is my point, this is my slope. It is y minus 1 is equal to negative 1 x minus 1. So now this is going to be L of X. I'm going to add 1 to both sides, add 1 to the other side. And since this is just a -1, okay, actually, you could just leave it like this. There's nothing wrong with this. Okay, it doesn't tell us to estimate anything, so that's fine. That's our linear approximation. Let's move on to the last page. So there's more practice here. This was actually one of the questions that were on the problem set. I just want to make sure that everyone is able to do this, especially with a product rule with implicit differentiation. A lot of you are still having trouble doing product rule. And especially product rule with implicit differentiation. On that last test, that's where a lot of you messed up on, like I told you before. So this was on the homework, and I'm going to do the problem here just to make sure everyone knows how to do this, because you're definitely getting an implicit linear approximation on the test. And I want to make sure that you could do a product rule with implicit differentiation. So let's go ahead and differentiate this. The left side, I don't think anyone has any issues with. The left side is just 2x plus 3y squared dy dx. Since we're doing implicit differentiate, we have a y here, so dy dx. Now let's go ahead and do the implicit differentiation here. So this is going to be first times the derivative of the second. So the first function is 2x squared times the derivative of y, which is dy dx. So once again, the derivative of y is 1. But since we're taking everything with respect to x, I put dy dx. Plus the second function, which is y, times the derivative of the first. The derivative of 2x squared is just 4x. Okay, so now once again, we're going to solve for dy dx. So I'm going to get everything dy dx on one side, everything that does not have a dy dx on the other side. So this is 3y squared dy dx minus 2x squared dy dx is going to be equal to 4xy. I just changed the order there. Minus 2x, because this goes to the other side. I'm going to factor out the dy dx. I get 3y squared minus 2x squared is equal to 4xy minus 2x. And I just divide both sides by 3y squared minus 2x squared. So all of this cancels. And then I'm just going to go ahead and plug in 1, 1. So this is 4 times 1 times 1 minus 2 times 1 over 3 times 1 squared minus 2 times 1 squared. So the top is just 2 and the bottom is just 1. So dy dx is just 2. And so this is just going to be y minus 1 is equal to 2x minus 1. So I'm using this point and I'm using this slope to write my linear approximation. And then so I know that L of x is equal to 2 times x minus 1 plus 1. And now I'm going to use this to approximate y of 1.2. So L of 1.2 is equal to 2. And if I just put that into my calculator, I get that this is equal to 1.4. So I know that y of 1.2 is approximately 1.4. Okay, 15. I'm evaluating this limit, so this is L'Hopital's rule. If I plug in 0 here, e to the 0 is 1. E to the negative 0 is also 1, so the top is 1 minus 1. And so it's 0 on top, and then it's 0 on the bottom. Cool. So I know that the limit as x approaches 0 of e to the x minus e to the negative x is equal to 0. And the limit as x approaches 0 of x is also equal to 0. So it's indeterminate form. Zero over 0. So then that means by L'Hopital's rule, the limit as x approaches 0 of this function. Okay, so that's just the setup. Now, what is L'Hopital's rule exactly? So if I have indeterminate form, I could just take the derivative of the top and take the derivative of the bottom and then plug in 0. Okay, so what is the derivative of the top? Well, the derivative of e to the x is just e to the x minus the derivative of e to the negative x is e to the negative x. But this is not just an x, it's a negative x, so you have to do chain rule here because the x is not by itself. And the derivative of negative x is negative 1. Whoops, I forgot to put is equal to the limit here. Yes, you need to include the limit here. If you don't, you'll be marked off. Over the derivative of x is 1. So this is just equal to the limit as x approaches 0 of e to the x plus e to the negative x, right? Negative 1 times negative, it makes it plus now. And now if I plug in 0, I get e to the 0 plus e to the negative 0, which is just 1 plus 1. And so our limit here is 2. Number 16, if I plug in 1 on the top, 1 minus 5 is negative 4. Negative 4 plus 7 is 3. 3 minus 3 is 0. So I know the top goes to 0. On the bottom, 1 minus 4 is negative 3. Plus 5 is 2. 2 minus 2 is 0. So I know the top and the bottom go to 0. So the limit as x approaches 1 So I have indeterminate form. Zero over 0 by L'Hopital's rule. The limit as x approaches 1 of this mess here. Is equivalent to the limit as x approaches 1 of the derivative of the top and the derivative of the bottom. So the derivative of the top is 3x squared minus 10x plus 7 all over 3x squared minus 8x plus 5. Okay, let's do a quick check to see if we're done. 3 times 1 is 3. 3 minus 10 is -7. -7 plus 7 is 0. Okay, so we have 0 on the top. If I plug 1 on the bottom, that's 3 minus 8 is -5. -5 plus 5 is 0. So once again, I have 0 over 0. So that means I could apply L'Hopital's rule. Now, you don't need to write all this over again. I'll be fine with you just saying by L'Hopital's rule. The limit as x approaches 1 of 3x squared minus 10x plus 7 over 3x squared minus 8x plus 5 is the same as, so now I'm going to take the derivative of the top again. So this is 6x minus 10 all over 6x minus 8. Okay, now if I plug in 1, I'm not going to get 0 over 0. 6 minus 10 is not 0. So this is equal to 6 times 1 minus 10 over 6 times 1 minus 8. So I have 6 minus 10 and 6 minus 8. So this is -4 over -2. And that is equal to 2.